we're going to cut that part off. So today we're going to talk about starting chapter 3. So chapter 3 is using the tools of geometry. And at this point, you probably have no idea what that means. So we're going to go ahead and take a look at what they're talking about here. So when we're going to be in this class from now on, there's going to be kind of three separate things that you might be asked to do here when it comes to creating a geometric figure. So far, what we've done is we've used sketching. Sketching is just a quick drawing, quick sketch. It doesn't need to be to scale. It's not measured in any way. What we're relying on is adding marks to our picture, congruent marks, perpendicular marks, things like that to show what things we think are true. We could also draw, which would mean using things like a ruler and a protractor to measure out exactly how long a line segment is or how big an angle is. But what we're going to be talking about this chapter is constructing. And so when we talk about constructing in geometry, that's a very, very specific thing. And when we talk about constructing, we're using two tools. We're using a compass and we're using a straight edge. So a compass is this thing. And you've probably used something like this before. It's got one end that just has a point, so it sticks into your paper. And it's got another end that turns so you can draw an arc of some sort. You might also have used one that looks like this. Right? It's called a safety compass. It doesn't have a pointy end, so you can't hurt your fellow classmates when you're in elementary school and drawing circles with these things. So up until this point, you've probably used these mostly, if you used them at all, for drawing circles, either in an art class or in some sort of a class in elementary school when you were drawing circles. In geometry, and really anytime you see a tool like this in real life, it's not actually used for drawing circles, almost never. What it's really used for is measuring, or rather copying distances. You can see that there are some marks on here. So this tool does allow you to measure a distance with it. Same thing over there. One side's inches, one side centimeters. A classic compass, and when I say classic compass, I'm referring to the ancient Greeks doing constructions. So this is really one of the first types of math ever done. Never had measurements on there. In fact, they didn't have numbers like that at all. Same thing with the straight edge. We're going to use probably a protractor because it has a straight edge along the end. But in classic geometry, there are no measuring systems. So you can see on there are inches on there. We're not going to use those inches. Now, a lot of times you'll hear people say things like, construction guarantees that your triangle is equilateral, or it's more accurate than measuring. That's not true at all. There's no world in which using a compass and a straight edge without any marks on it is more accurate than just using a ruler and a protractor to get angles and lines. That's not why we do constructions. We still use constructions. We still have you do constructions in geometry because they are mathematically meaningful. The things that we actually do with these tools actually have real analogs in the math that we're going to be learning this chapter, and most importantly into next chapter. And that's where we come into things like this. This is like the original math textbook. Okay, this thing was written by somebody named Euclid, like way back 3,000 or so years ago in Greece, when they first started doing constructions. So if you were just open to a random page here, one thing you're going to notice for a math textbook, there are absolutely no numbers anywhere to be found in this entire book besides the numbers of the propositions. Every single thing in here is completely lacking numbers. And so math was done entirely without numbers at that point. It wasn't really, when we're talking about math like this, it wasn't at that point a useful thing. This was something that people that had free time for the first time in history, you've learned about that in your world history classes, hopefully, are really starting to explore, things that don't really have necessarily uses, but are interesting, and they have time to do them as kind of a little, side project when they're not doing whatever else, because they don't have to go and work in the field anymore. And so a lot of these were actually more like puzzles. The goal was to take these basic tools, a compass and a straight edge, and to try to construct everything that they thought existed. So they started off with things like lines and points and things like that. which, if you have a straight edge, you can draw a line. If you have a pencil, you can draw a point. But then they worked into things like, if I have a line segment, could I construct using just those tools an equilateral triangle? And so that's actually Euclid's proposition 1. He goes through the steps for how to construct an equilateral triangle using only a compass and a straight edge. And from there, he just keeps going. They did things like copying the length of a segment, which is how you construct an equilateral triangle. Copying an angle, bisecting, which means to cut in half a segment, creating parallel and perpendicular lines, creating right angles. Any of those things that we've talked about in chapter 1, we're going to learn how to construct those using just these two tools. So when we construct these in class, we're going to use an actual real compass and an actual physical straight edge. But when you go home and you're doing a few of these at home, and for the A group, you're going to be doing your first version of this Friday at home, we're going to use a tool. It's called MathPads. I can't say it. It's a British website. Mathspad.co.uk has a nice little geometry construction tool. And so they've actually got a protractor tool and they've got a straight edge tool. And when you use that straight edge, no matter what, you'll always draw a straight line. They've also got a protractor tool. I'm not actually sure how that works. We're not going to use that really. They've got a line segment tool, so you can create a line segment of some sort. And it's got some nice features. It's going to automatically snap to the end of line segments and things like that. You can lock it in place. Just like if you took your compass, every compass I've ever seen has some sort of way to lock it. You can tighten that screw and it won't move anymore. You've got the same thing there. Then you can move it around and use it to draw an arc. Now, of course, you can draw a circle. Maybe you can draw a circle. There you go. But like I said, compasses really traditionally aren't used for drawing circles. So one of the first things that we're going to do is we're going to learn how to copy a line segment. So I will, that'll be the thing that you're doing tomorrow. But for now, I just want to show you the compass here in real life, just to give you a couple of hints here. So you've seen a compass, hopefully before. If you haven't, that's what this is. You've got one pointy end. You've got one end that's a pencil. A couple of really key points here. When you close them up, they should be pretty much touching each other. If they aren't, you're going to have a little bit of problem. And then it should be tight enough that you can kind of move it around, but it's not going to wiggle around on you accidentally. When you go to use it, a couple of things that I've found very helpful. First of all, number one, you're almost never drawing a full circle. So don't draw a full circle. Put the pressure on the actual point of the compass. You can actually, if you're doing this on a notebook, or I've actually got a stack of paper here, you can stick that point right into the paper. Then I'm just barely putting any weight at all on the pencil. That's going to get me my best arc. However, I'm going to do that. So just simple things like that are going to help out. It takes some time to get used to using these things by hand. It's not something you really are used to. Straight edge or a ruler, pretty simple there. You're just not allowed to use the line, the markings on it. So that's all there is to that one. Put this back up here. So like I said, we're going to talk about 6 basic constructions this year. Kind of the goal is going to be that you know those 6 constructions. It's kind of the minimum level of what I need to see out of you for this year. So that's going to be to copy a segment, to copy an angle, to bisect a segment, bisect an angle, create a perpendicular line through a point on the line, and create a perpendicular line through a point not on a line. Now, there are other things we're obviously going to want to do besides those 6 things, but they're all based off of those 6 things. So we'll make parallel lines. We'll make triangles. We'll make right triangles. We'll make squares. We'll make a rhombus. But if you think about what some of those words mean, right triangle. If you can make perpendicular lines, you can make a right triangle. an equilateral triangle has equal sides. If you can copy a segment, you can make an equilateral triangle. So everything else is going to be based on those 6. And honestly, most of those 6 are based on the first 2 or 3. If you can copy a segment and you can bisect a segment, all the other ones are based off of those 2. So tomorrow, you're going to have a video on how to copy a segment. I'll show you both with this real compass as well as the online tool, what that looks like. And for this first one, since you're going to be at home while you're doing this, I'm going to have you doing this on a Google Cloud assignment. And what that's going to be is it's going to be some questions and then a spot to upload a picture into. And so your picture can either be, your paper. The arcs are absolutely critical. Those are how I see what you did. Just because you ended up with a line segment that looks the same as the one you started with doesn't mean you actually did a construction. So your actual work with the construction marks still in place, or a screenshot of what you've done on here. And again, I'm going to need to see the construction lines, not just 2 lines that look the same. So keep that in mind. I will obviously show you that tomorrow when we talk about how to construct a copy of a line segment. So other than that, you're coming back tomorrow to watch that video, and then I will see the A group on Monday. B group, we're going to talk about that stuff actually in class, so you get the lucky draw there. But yeah, see you later.